This video, we'll be discussing about Physics Paper 2 AS Level Structured Question 2023 May June Variant is 21 and the subject code is 9702. Question number 1 Part A. Define power. So we know that power is equal to work done per unit time or energy per unit time. Energy per unit time. So work done per unit time. Then use the definition of power to show that the SI base unit of power are kg meter square per second cube. So we need to show that the SI unit of power is kg meter square per second cube. So first of all, we know that power is equal to work done by time taken. And we know that work done is equal to force into distance by time. So force is equal to mass into acceleration. So the SI unit of mass is kilogram, and for acceleration it is kilogram, and the acceleration it is meter per second square. So kilogram meter per second square, there is force, there is mass into acceleration. Force is equal to mass into acceleration. So force is equal to mass into acceleration. That is kilogram. The SI unit of mass is kilogram. For acceleration, it is meter per second square. And the SI unit of distance is meter. And for time, it is second. So if we just cancel, then nothing to cancel, but we need to rearrange that it would be kg meter square per second cube. So kg meter square per second cube as shown. Then the intensity of a sound wave moving through a gas is given by intensity is equal to this expression, where f is the frequency, a is the amplitude, v is the speed, and k is a constant that depends on the gas. So k is a constant. Determine the SI base unit of k. Now we need to find the SI base unit of k. So first of all, to find the SI base unit of k, so we need to find each of this SI base unit, that is for intensity. So first of all, we need to deal with intensity and find the SI base unit of intensity. So we know that intensity is equal to power per unit area. So intensity is equal to power per unit area. And for power, we found the SI base unit as kg meter square per second cube. So kg meter square per second cube. And for area is the cross-sectional area. So the unit would be meter square. So the area is meter square. And if we just rearrange this, then it would be meter square and meter square cancel. And the SI base unit of intensity is kg per second cube. So we know the SI base unit of intensity. Now, what is the SI base unit for frequency, amplitude, and velocity? So what is frequency? Frequency is equal to 1 by time period. Frequency is equal to 1 by time period. So 1 by time period square, then amplitude square, Vk. So the SI base unit of intensity is kg per second cube. For 1 by time square is 1 by second square. So the SI base unit of time is second. For amplitude square, so it is meter square. Since amplitude is the length, so the unit would be meter. And since it is amplitude square, so meter square. Then velocity is meter per second and k. So kg per second cube is equal to second to the power negative 2. So if we move second upwards, then it would be second to the power negative 2 meter square meter per second k, where k is the constant, and we need to find the SI base unit of k. So kg per second cube is equal to meter square, and meter is meter cube, second to the power negative 2 into second to the power negative 1. So second to the power negative 2 into second to the power negative 1. Since the base is same, so we need to add the power, that is negative 2 plus negative 1 is negative 3 and k. So if we just write this place, so kg per second cube is equal to meter cube, second cube, and k. So we need to find the SI base unit of k. So second cube and second cube cancel, and the SI base unit of k is kg per meter cube. So kg per meter cube is the SI base unit for k, that is kg per meter cube. Question number 2. A rigid uniform beam of weight W is connected to a fixed support by a hinge as shown in figure 2.1. So the beam is connected to a fixed support by a hinge, this hinge, and the beam has a weight of W, and since it is an uniform beam, so since the beam is uniform, so the weight is acting from its center. Since it is an uniform beam, so the weight is acting from its center, that is the weight W, and since weight is a force that is acting vertically downward. A compressed spring exerts a total force of 8.2 Newton vertically upward on the horizontal beam. So the spring exerts a vertical force of 8.2 Newton. So remember that this force is vertical and it exerts a force that is upward. A block of weight 0.30 Newton rests on the beam. So the block rests on the beam and has a weight of 0.30 Newton. The right hand end of the beam is connected to the ground by a string at an angle of 30 degrees to the horizontal. So right hand end, that means this end is connected to the ground by the string at an angle of 30 degrees to the horizontal. So we know the value of force, and this force is acting at an angle of 30 degrees. So for this force, we can only deal with the forces when they are in horizontal direction or in vertical direction. So we need to find the horizontal and the vertical component of 4.8 Newton force. So the horizontal component is in this direction and the vertical component is this direction. So the resultant force, that is 4.8 Newton, is this direction. So what is the horizontal component of 4.8 Newton that is acting at an angle of 30 degree? So 4.8. So since it is adjacent side, so 4.8 cos 30. Adjacent side is cos and the opposite side is sine. So the opposite side would be 4.8 sine 30. That is the horizontal and the vertical component of 4.8 Newton force. Then the tension in the string is 4.8 Newton. The distance along the beam are shown in figure 2.1. So the distances, that is the distance values, are given. The beam is in equilibrium. Now this is an important part, that is the beam is in equilibrium. That means at equilibrium we know that the resultant force is 0. At equilibrium, the resultant force is 0. That means the upward force is equal to the downward force and the resultant moment is 0. That means clockwise moment, that is the clockwise moment, is equal to anti-clockwise moment. So the resultant force is 0 and clockwise moment, this is the clockwise moment, is equal to the anti-clockwise moment. Since clockwise moment is equal to anti-clockwise moment, so the resultant moment is 0. So at equilibrium, the resultant force is 0. That is the upward force is equal to the downward force and the resultant moment, that is the clockwise moment, is equal to the anti-clockwise moment. So assume that the hinge is frictionless. So there is no friction at the hinge. Show that the vertical component of the tension in the string is 2.4 Newton. So the vertical component of the tension in the string. So tension in the string, that is 4.8 Newton. So tension in the string is 4.8 Newton. So for this 4.8 Newton force, that is by the tension, we need to find its vertical component. So the vertical component, we have found that it is 4.8 sine 30. So 4.8 sine 30, and if we just calculate by using a calculator, then it would be 2.4, correct to two significant figures. So 2.4 Newton as shown, SHOWN as shown, and it is Newton. Then taking moment about the hinge, determine the weight of the beam. So we have to remember that the beam is in equilibrium. That means the clockwise moment is equal to the anti-clockwise moment. So what are the clockwise and anti-clockwise moment? So first of all, clockwise moment, that is CW, and anti-clockwise moment, that is AW. Clockwise, so clockwise CW, and the anti-clockwise, so anti-clockwise, so ACW. So clockwise moment is equal to anti-clockwise moment. That means the resultant moment is 0 and the beam is in equilibrium. So we need to equate the clockwise moment is equal to anti-clockwise moment. So what are the clockwise moment? So first of all, if we just erase this, then here this is the beam, and the forces that causes the beam to move in this direction are the clockwise moment, that is in the clock direction. So in the clockwise direction or in the clock direction, as the clock moves, it moves in this way. So the forces that cause the that causes the beam to move in this direction are the clockwise moment. So what are the clockwise moment? So as we can see that the weight and the 0.30 Newton force are causing the beam to move like this way, something like this way, or downwards, and eventually like this way. So they are the clockwise moment. So clockwise moment is weight and the so first of all, what is moment? So moment is equal to moment of force is equal to force and the perpendicular distance from the pivot. So moment of force is the product of force and the perpendicular distance from the pivot. So for the weight, that is the clockwise moment, so the weight is W. We refer this as W since we need to find the weight as W. So we need to find the value of W. So we consider it as W. So the force and the perpendicular distance from the pivot. So this is the pivot and this distance is perpendicular distance. So W and the distance is 0.50 plus 0.10, that is 0.60. So 0.60 into W. So moment of force is equal to force into this perpendicular distance from the pivot. So 0.60 into W. Similarly, as wave, weight, this force, that is 0.30 Newton, is also causing the beam to move in a clockwise direction. So 0.30 Newton, and the distance from the pivot, that is this pivot, is this distance, that is 0.50 plus 0.10 plus 0.20, that is 0.5 plus 0.1, that is 0.6, 0.80. So force and the perpendicular distance, so this force, that is 0.30, and the perpendicular distance, that is this distance, is 0.30 into 0.80 plus the vertical component of this string. So the vertical component. Now, why we consider the vertical component and not the horizontal component? Because we know that the moment of force is the force and the perpendicular distance from the pivot. So the distance have to be a perpendicular distance. Now, if we consider the horizontal force, then the perpendicular distance from the pivot is 0, because as the force is horizontal, the distance is also horizontal. As the force 4.8 Newton, 4.8 cos 30 is the horizontal force. So since it is a horizontal force, so the force is horizontal and the distance is also horizontal. So it is not perpendicular. But for the vertical component, the force is vertical and the distance is horizontal. So force and the perpendicular distance from the pivot. So that's why we need to consider the vertical component and only the vertical component and not the horizontal component. So 4.8 sine 30, that is 4.8 sine 30 is 2.4 Newton. So 2.4 Newton, and the perpendicular distance from the pivot, that is this perpendicular distance is, so from the pivot to this point, since this is the end point of the beam. So 0.5 plus 0.1 plus 0.2 plus 0.4, that is this distance. So 0.8 plus 0.4, that is 1.2. So 1.2 into 2.4, and these are the clockwise moment. So what is the anticlockwise moment? Now, the only anticlockwise moment from this diagram is caused by the spring, that is 8.2 Newton, that is acting vertically. So 8.2 Newton, that is vertically upward. So 8.2 Newton, and the distance from the pivot is 0.50, and it is the perpendicular distance. So after substituting the value, we get the weight as 1.6 Newton. So the weight is 1.6 Newton. Now calculate the horizontal component of force exerted on the beam by the hinge. So this is an important and easy part, that calculate the horizontal component of force exerted on the beam by the hinge. So we need to calculate the horizontal component of force exerted by the hinge. So what is the force exerted by the hinge? That is this hinge. So we need to remember that the system is in equilibrium, and at equilibrium the resultant force is 0 and the resultant moment is 0. Since the resultant force is 0, that means the force on the up is equal to the force on the down, and the force on the right is equal to the force on the left. So now we need to deal with the horizontal component of force. So we need to find that are there any other horizontal forces are acting, and you have to remember that at equilibrium the resultant force is 0. That means the sum of the horizontal component of forces must be 0. So if resultant if horizontal, that is resultant if horizontal is 0. So we know that the resultant force on the horizontal direction is 0. That means the force on the right is equal to the force on the left, because the system is in equilibrium. So the resultant force on the horizontal direction is 0. So since the resultant force on the horizontal direction is 0, and the only horizontal force is acting is by 4.8 Newton, that is, if we break the force into its component, then the adjacent side is 4.8 cos 30. So 4.8 cos 30, and this force is acting on the right. So at equilibrium, we know that the resultant force on the horizontal direction is 0, or the resultant force is 0. And for horizontal direction, since this force is acting on the right, so there must be an equal force that is acting on the left. So the force have to be equal in magnitude but acting in opposite direction. That means since this force is acting on the right, so a force of equal magnitude is acting on the left. And if we just calculate the magnitude of this force, then it would be 4.15 or approximately to 4.2 to significant figures. So 4.2 to 2 significant figures, that means this force is acting on the right. That is 4.2. So to balance this force, there must be an equal and opposite force of 4.2 Newton that is acting on the left. So the left force is equal to the right force. That means the forces are cancelled and the system is in equilibrium. So since the system is in equilibrium, so the resultant force on the horizontal direction is 0. That means the force on the right is equal to the force on the left, and the force on the right we have calculated that 4.2 Newton. So the force on the left must be 4.2 Newton. So the force by the hinge is acting on the left and is 4.2 Newton. So we need to find only the magnitude. So this is 4.2 Newton. It obeys Hooke's law and has an elastic potential energy of 0.32 joules. Calculate the compression of the spring. So where is the spring? So this spring obeys Hooke's law. That means force is directly proportional to extension. So for Hooke's law, we know that force. So for force extension graph, since force is directly proportional to extension, so for Hooke's law, force is directly proportional to extension. That means the force extension graph is starting from a zero value and is a straight line. So for Hooke's law, force is directly proportional to extension, and we need to find the compression of the spring. So we have given the elastic potential energy, and so force is directly proportional to extension for Hooke's law. And for elastic potential energy, we know that elastic potential energy is the area under the force extension graph. So you have to remember that the elastic potential energy is the area under the force extension graph. That is the area of the triangle. So since the force extension graph is a straight line, so here we can see that the shape that is formed is a triangle or a right angle triangle. So the area of the right angle triangle would be, that means elastic potential energy is equal to half, that is the area of the right angle triangle is half into base, that is x, and the height is f. So half fx. So elastic potential energy is equal to half fx, and we have given the magnitude of elastic potential energy as 0.32. So 0.32. So we know the value of elastic potential energy. So what is the value of force? So we know the force exerted by the spring. So the force by the spring, that is this spring. So what is the force by the spring? So a compressed spring exerts a total force of 8.2 Newton vertically upward. So the force exerted by the spring is 8.2 Newton. So we know the value of force, that is 8.2 Newton. So extension is equal to 0.32 into 2 by force, and the force is 8.2 Newton. So after substituting the value, we get the compression as 0.078, that is two significant figures. And how I determine that this is two significant figure? That means if we write this in the exponential form or in the 10 to the power form, then it would be that 0.078. So if we move the 0, then 1, 2. So it would be 7.8 into 10 to the power minus 2. So you can easily get that this is two significant figure. So this is the compression of the spring. And so from this question, you have to learn that the elastic potential energy is the area under the force extension graph. That is, elastic potential energy is equal to half fx, since it is a right angle triangle. The string is cut so that the spring extends upward. This causes the beam to rotate and launch the block into the air. So what happens? So this string is cut, and so the block launches upward because the spring causes the block to launch upward. So the string is cut and the spring causes the block to move upward. So the string is cut so that the spring extends upward. This causes the beam to rotate and launch the block into the air. So the block is now launched into the air. The block reaches its maximum height and falls back to the ground. So the block, suppose from the beam, it moves, and as it moves, it reaches its maximum height and then it falls. So from maximum height, it falls like this way. So as it is launched, it reaches its maximum height, then it falls downwards. So figure 2.2 shows the part of the path of the block in the air shortly before it hits the horizontal ground. So this is the path of the block before it reaches the ground. Now the block is at a height of 0.090 meter. So the vertical height is 0.090 meter above the ground when it passes through point A. So when it at point A, suppose any random point at point A, it is at a height of 0.090 meter. The block has a kinetic energy of 0.044 joules when it hits the ground at point B. So before reaching point B, or when it hits the ground at point B, it has a kinetic energy given. And the air resistance is negligible. That means there is no resistive force due to air resistance. Calculate the decrease in gravitational potential energy of the block for its movement from A to B. So what is the decrease in gravitational potential energy? So for the block, we know that gravitational potential energy is equal to mass into gravitational field strength into vertical height. So we know the value of vertical height, that is 0.090 meter. So we know the value of vertical height, and what is the mass into gravitational field strength? So you have to remember that mass into gravitational field strength is also weight. That is, weight is equal to mass into gravitational field strength. And initially we know that the weight of the block is 30 Newton. So for this block, this is the block, and it has a weight of 30 Newton. Sorry, this is 0.30 Newton. So the block has a weight of 0.30 Newton. So weight of 0.30 Newton. So weight of 0.30 Newton, that means the mass into gravitational field strength, and the vertical height is 0.090. So what is the gravitational potential energy or the decreasing gravitational potential energy? That is mass into gravitational field strength to height, that is 0.027 to 2 significant figure. And again, if we move the 0, then it will be 1, 2. So 2.7 into 10 to the power minus 2. So this is 2 significant figure, that is 1, 2. Then use your answer from C1 in C1 and the conservation of energy to determine the speed of the block at point A. So we need to find the speed of the block at point A. We need to find the speed of the block at point A. That is, at point A, we need to find the speed. So by conservation of energy, we know that the energy is always conserved. So total kinetic energy before reaching the ground is equal to the kinetic energy plus gravitational potential energy at point A. So that means kinetic energy or EK at point B, that means before reaching the ground, it has a total kinetic energy. And since before reaching the ground, we assume that almost it touches the ground. So as it touches the ground, so the vertical height is 0. That means at point B, since the vertical height is 0, so it has only kinetic energy. So the total energy is the kinetic energy. Since the total energy is the kinetic energy, so the total energy at B is equal to the total energy at A. So since total energy is equal to total energy, so the energy is conserved. So what is the total energy at A? Total energy at A is equal to kinetic energy at A plus gravitational potential energy at A. That is GPE. So GPE at A, or gravitational potential energy at A. So I refer the gravitational potential energy as EPM, that is energy, gravitational potential energy, or you can refer this as GPE as you wish. So kinetic energy at B, that is, the block has a kinetic energy of 0.044 joules when it reaches the ground at point B. That means the total energy at B is 0.044 joules. So total energy at B is equal to total energy at A, that is the kinetic energy at point A plus the gravitational potential energy at point A. So we know the gravitational potential energy at A. So this is the gravitational potential energy at A, that is the decreasing gravitational potential energy. So this energy is the gravitational potential energy, that is 0.027 plus kinetic energy. So what is the value of kinetic energy? We know that the equation for kinetic energy is half mv square. So half and the mass into v square. So v square, and we need to find the speed. So that is v. So what is the value of mass of the block? So initially we know that the weight of the block is 0.30 Newton. So we know the weight. So weight is equal to mass into gravitational field strength. So what is the value of mass? Mass is equal to weight, that is 0.30 by gravitational field strength, that is 9.81. So 0.30 divided by 9.81. So this is the mass into v square. So after rearranging and calculating, we get the v as 1.1 meter per second to significant figure. A reference to the force on the block explain why the horizontal component of velocity of the block remains constant as it moves from point A to point B. So why the horizontal component of velocity is constant? So for the block, suppose as the block moves, so for this block, the only force that is acting on the block is its weight. Suppose this is the block that we have given, and the only force is acting on the block is its weight, that is 0.30 Newton. So for the block, the only force that is acting is 0.30 Newton, that is vertically downward. So the weight is acting vertically downward of 0.30 Newton. So the weight is acting vertically downward, and we know that weight is equal to mass into gravitational field strength, and the gravitational field strength is the acceleration, or gravitational field strength is the acceleration, and the gravitational field strength is 9.81 meter per second square. So the acceleration is 9.81 meter per second square. So since the weight is acting vertically downward, or we know that force is equal to mass into acceleration, so the force is acting vertically downward, so the acceleration is also acting vertically downward. And as the weight is acting vertically downward, so the weight is acting vertically downward, that is 0.30 Newton. So the gravitational field strength must also act vertically downward. So the gravitational field strength, we know that it is acting vertically downward, and in the horizontal direction, there is no other forces acting on the block, because we know that the air resistance is negligible. So in the horizontal direction, there is no other force that is acting on the block. Since in the horizontal direction, there is no forces acting, and we know that force is equal to mass into acceleration. since in the horizontal direction there is no forces acting, so since the forces in the horizontal direction is 0, so though the block has some mass, but acceleration is 0. Since the force is 0, so the acceleration is 0. That means in the horizontal direction there is no acceleration. So since there is no acceleration in the horizontal direction, there is no acceleration, or the acceleration is 0. And here we need to state why the horizontal component of velocity of the block remains constant. So for the horizontal component, we know that in the horizontal direction the resultant force is 0, so the acceleration in the horizontal direction is 0. And since the acceleration is 0, so we usually know that when acceleration is 0, then velocity is constant. So velocity is constant. So when acceleration is 0, velocity is constant. Therefore, why the velocity is constant? Because why the velocity in the horizontal direction is constant? Because the acceleration is 0. And why the acceleration is 0? Because the resultant force on the horizontal direction is 0. So we can say that the resultant force on the horizontal direction is 0. So the acceleration on the horizontal direction is 0. And since the acceleration is 0, so the velocity is constant. Or we can simply say that the only force that is acting is the weight, that is the vertical force. So only force, that is the vertical force, that is the weight. Since the force is vertically downward, so the acceleration is also vertically downward. So acceleration is vertically downward, and so the velocity vertically changes, but horizontally no force is acting. Since no force is acting in the horizontal direction, so the acceleration is 0, because force is equal to mass into acceleration. So force is 0, acceleration is 0, and therefore the velocity is constant. It's better for you to write the full answer, because it would make you to understand that the only force that is acting is the weight. So for the block, the only force that is acting is the weight, that is the vertical force. So in the horizontal direction, no force is acting on the block. So no force is acting on the block. That means the force on the horizontal direction is 0. So no force is acting in the horizontal direction, and since no force is acting, so we know that since force is 0, so from the equation we know that the acceleration is also 0. So since the force in the horizontal direction is 0, so the acceleration is 0. And for acceleration 0, we know that for 0 acceleration, the velocity is constant. So for 0 acceleration, the velocity is constant, and therefore the velocity of the block is constant as it moves from point A to point B in the horizontal direction. The block passes through point A at time ta and arrives at point B at time tb. So from Ta to tb. On figure 2.3, sketch a graph to show the variation of the magnitude of the vertical component By of the velocity of the block with time from time Ta to time tb. Numerical values of Vy are not required. So numerical value is not required, and we need to draw a graph of vertical component of velocity Vy. And we know that for the block, so for the block from point A to point B, and we know that the block, this is our block, and in the vertical direction only the weight is acting vertically downward, and in the vertical direction only weight is acting vertically downward, and there is no other forces acting in the vertical direction. Since there is no other force that is acting in the vertical direction, so our only force is the weight, and we know that weight is equal to mass into gravitational field strength. So gravitational field strength, and we also know that force is equal to mass into acceleration. So what is the acceleration for the block? So the acceleration for the block is equal to g, and we know that g is 9.81 meter per second square. So the acceleration is 9.81 meter per second square, and this value of g is constant, so acceleration is also constant. So the gravitational field strength is constant, that means the acceleration is constant. So we know that for velocity time graph, the gradient of the velocity time graph is the acceleration. So for velocity time graph, the gradient of the velocity time graph is acceleration, and the area under the velocity time graph is the displacement. So the area under the velocity time graph is the displacement, and the gradient of the velocity time graph is acceleration. So the gradient is acceleration, and here we know that the acceleration is constant, that is 9.81 meter per second square. Since acceleration is constant, so the gradient for the velocity time graph would also be a constant and a straight line. So the gradient of the velocity time graph would be a constant and a straight line, since the acceleration is equal to the gradient of the velocity time graph, and as acceleration is constant, so the gradient of the velocity time graph is also a constant and a straight line. And so the gradient of the velocity time graph is the acceleration, and acceleration is a constant and a straight line, and the value of acceleration is 9.81, but we don't need to write any numerical value. So the gradient of the velocity time graph is acceleration. Now, why the velocity time graph does not start from a zero value? Instead of why the velocity time graph is not starting from a zero value? Why it starts from a value that is above zero? Because for time ta, so for time ta, the block is at point A, and we know that the block, as the block is moving, so it is moving like this way. Since it is moving like this way, and here it is not mentioned that point A is the topmost point, and here we can also see that the block is not at the topmost point. Instead, the block is moving downwards from a lower point. Instead of moving from a topmost point, it is moving from a lower point, and we know that at the maximum point or at the highest point, the velocity is 0. But since the block is not at the highest point, that is not mentioned, so the block is not at the highest point, so the velocity is not 0. Instead, it has some velocity. So it has obviously some velocity, and at the topmost point the velocity is 0, but it is not mentioned that the block is at the topmost point. So at point A, it has obviously some velocity, since it is not the topmost point, or it is not the maximum point. And at maximum point the velocity is 0, but it is not mentioned that point A is the maximum point. Since point A is not the maximum point, so it has obviously some velocity. That is, it has obviously some velocity that it starts from a value that is greater than 0 and a straight line with a constant gradient. Question number 3. A block is pulled in a straight line along a rough horizontal surface by varying force X, as shown in figure 3.1. So the force X is the forward force, and as the force is varied, the object moves and the surface is a rough surface. That means there is an effect of friction, that is mu r, or there is frictional force. Air resistance is negligible. Assume that the frictional force exerted on the block by the surface is constant and has a magnitude of 2 Newton. So the frictional force is constant and has a magnitude of 2 Newton. The variation with time of the momentum of the block is shown in figure 3.2. So for this block, the variation of momentum against time graph. So it is momentum against time graph. State Newton's second law of motion. So what is Newton's second law of motion? So for Newton's second law, force is equal to mass into acceleration. Also, force is equal to change in momentum by change in time. And in S level, when we need to write the definition, we need to write this definition. That is, resultant force on an object is equal to the rate of change of momentum. So resultant force, that is the resultant force F is equal to change in momentum by change in time, or rate of change of momentum. So rate of change of momentum or change in momentum by change in time. Then use figure 3.2 to determine for the block at time 2 seconds the magnitude of the resultant force. So we need to find the magnitude of the resultant force, and we have given the time, that is 2 seconds. So what is the resultant force? We know that resultant force is equal to change in momentum by change in time, and we have given the value of time. So what is the change in momentum? So usually we have given a graph of momentum against time. So for time t is equal to 2 seconds, we find the momentum, that is 3. So change in momentum, that is 3. So change in momentum is equal to final momentum, that is 3, and the initial momentum is 0. So the change in momentum is 3. What is the resultant force? Resultant force is equal to change in momentum, that is 3, by change in time, that is 2. So 3 by 2 or 1.5. So the resultant force is 3 by 2 or 1.5 Newton. The force X. So what is the value of force X? So we know the value of resultant force. Now the resultant force is equal to forward force F forward minus F backward. So resultant force is equal to forward force minus backward force. And so we need to find the force X, that is the forward force. And we know the backward force of 2 Newton. So the backward force is 2 Newton, that is the frictional force. And we need to find the forward force X. So the backward force is 2 Newton, the forward force is X, and the resultant force, that is the resultant force, is 1.5 Newton. So after calculating, we get the value of X as 2 plus 1.5, that is 3.5 Newton. So the value of X is 3.5 Newton. 3.3. Sketch a graph to show the variation of force X with time from time t is equal to 0 to time t is equal to 6 seconds. And what is force X? So force X is our forward force. So resultant force, that is resultant force, is equal to forward force X minus the backward force of 2 Newton. So the resultant force is equal to the forward force X minus backward force of 2 Newton. And what is the value of resultant force? So first of all, from time t is equal to 0 to time t is equal to 4 seconds. So from time t is equal to 0 to time t is equal to 4 seconds, what is the resultant force? So resultant force is equal to change in momentum by change in time. So change in momentum is 6 minus 0. So 6 minus 0, and the change in time is 4. So change in momentum by change in time, so the resultant force comes to be 6 by 4 or 3 by 2, that is 1.5 Newton. So this is the resultant force. That is the resultant force R. Now we know the value of resultant force R, and we know that resultant force is equal to forward force X minus backward force of 2 Newton. So forward force minus backward force 2 Newton. So 1.5 is equal to X minus 2. So the value of X is 2 plus 1.5, that is 3.5 Newton. So the value of X is 3.5 Newton and the value is constant. So the value of X is 3.5 Newton and the value is constant, or the value is same. So from time t is equal to 0 to time t is equal to 4, the value of X is same. As we have calculated that the value of X is same, because here we can see that the resultant force is constant or same, and you have to remember that the gradient of momentum time graph is the resultant force, because if we see, then the velocity is equal to displacement by time. Velocity is equal to displacement by time. So for displacement time graph, the gradient of the displacement time graph is velocity. Gradient is equal to velocity. Similar to that, for momentum time graph, resultant force is equal to change in momentum by change in time. So for momentum time graph, the gradient of the momentum time graph, similar to displacement time graph, is equal to force, or the resultant force. Since the gradient of displacement time graph is velocity, so the gradient of momentum time graph is the resultant force. So the gradient of momentum time graph is the resultant force. And here we can see that the gradient is the resultant force and the gradient is constant and increasing. Since the gradient is constant and increasing, so the resultant force is constant. So the resultant force is constant and the backward force of 2 Newton is also constant. So the value of X is constant, or the value of X is same. That is, from time t is equal to 0 to time t is equal to 4, the value of X is 3.5 Newton. Then moving forward, that is for the next part. So let me erase this. Now here we can see that the gradient of momentum time graph is a straight line. So the resultant force is 0. Gradient of momentum time graph is a straight line or a horizontal line. So since the gradient is horizontal, or the gradient is 0. As the line is a straight line, so the gradient is 0. So the resultant force is also 0. Also we can calculate this. The resultant force is equal to change in momentum by change in time. So time is 4 to 6. That is, the difference in time is 2 seconds. That is, 6 minus 4 is 2 seconds. And what is the change in momentum? So final momentum is 6, and the initial momentum at this point is also 6. So 6 minus 6, that is, the change in momentum is 0 by 2. So the resultant force comes to be 0. The resultant force is 0. And since the resultant force is equal to forward force X minus backward force of 2 Newton. And since the resultant force is 0, so 0 is equal to X minus 2. So X comes to be 2 Newton. So the value of X is 2 Newton. And this value is also constant, or the value is same. So the value of X is 2 Newton. That is 2 Newton from time t is equal to 4 to time t is equal to 6 seconds. For question number 4, a beaker in air contains a liquid. The base of the beaker is in contact with the liquid and has area A. As shown in figure 4.1, so beaker, liquid, base area A, height h. The liquid has density rho and fills the beaker to a depth h. So the depth is h. By definition of pressure and density, show that pressure is equal to rho gh, where P is the pressure due to liquid exerted on the base of the beaker and g is the gravitational piston or the acceleration of free fall. So we need to derive the equation that is pressure is equal to rho gh. So first of all, we need to use the definition of pressure and density. So what is the definition of pressure and density? So pressure is equal to force by area and density. So pressure is equal to force by area and density. The definition of density is mass per unit volume. So density is equal to mass per unit volume. So density is equal to mass per unit volume. So pressure is equal to force per unit area. So we can also write force in terms of mass into acceleration. Since resultant force is equal to mass into acceleration, so mass into acceleration per unit area, and we can replace mass with density into volume. So mass is equal to density into volume. That is from this equation. So mass is equal to density into volume. M is equal to rho V. So pressure is equal to rho V acceleration by area. And what is V? Volume is equal to area into length. So volume is equal to area, cross-sectional area or the base area, and the length is h. So into h, A is the acceleration by A. That is the area. So area and area cancels, and here we get the equation that is pressure is equal to rho g h. Rho g h or rho h, and g is the acceleration of free fall. So acceleration or g is the same. So pressure is equal to rho g h. that is shown. Suggest why the equation does not give the total pressure on the base of the beaker. So what is the total pressure? Total pressure is equal to pressure due to liquid plus pressure due to air column or due to air or the atmosphere pressure. So by using this equation, we can find the pressure due to liquid. But since the beaker is in air, so obviously there is some atmospheric pressure acting. Since the atmospheric pressure is acting, so this is not the total pressure because the pressure we calculated is the pressure due to liquid column. So pressure due to liquid column, and also there is an atmospheric pressure. So there is atmospheric pressure acting, and atmospheric pressure plus pressure due to liquid column is the total pressure. Figure 4.2 shows the variation of total pressure inside the liquid with the depth below the surface. So the total pressure inside the liquid with the depth x below the surface. So pressure against depth x. So determine the density of the liquid. So we have given the variation of pressure against depth x. So we know the equation that is pressure is equal to rho g h, and here we have given the variation of pressure with depth x or the height. So pressure is equal to rho g and height is x. And we need to determine density. So density is equal to pressure by rho g, or density is equal to pressure by gx. So gx. And what is the pressure? So pressure is equal to, so we need to calculate the change in pressure because the pressure changes from 9.60 to 9.66. So what is the change in pressure? So change in pressure is 9.66 minus 9.60 into 10 to the power 4. 10 to the power 4 by g is the gravitational piston or acceleration, that is 9.81, and x is 8. So 8. So 9.66 minus 9.60 into 10 to the power 4 by 9.81 into 8. So what is the value? Also you have to remember that x is in centimeter. So we must need to convert this to meter. So x is in centimeter. So 8 centimeter divided by 100 to convert this to meter. So what is the answer? So the answer that we get is 764.525, or approximately to 764. 3 significant figures. So the answer is 764 as our final answer. Or if we just take the approximate value, then it would be 765 because there is a 5. So it would be 765. Since it is 5, so we need to add 1 to this value. So the approximation value is 765. So 765 is the final density. D. A solid cylinder is held stationary. So the cylinder is stationary by a wire so that the base of the cylinder is level with the surface of the liquid, as shown in figure 4.3. So the base of the cylinder is level with the surface of the liquid and the cylinder is stationary. Since the cylinder is stationary, so by Newton's first law, we can say that the resultant force is 0, because when the object is stationary or moving at a constant velocity, the resultant force is 0. So resultant force is 0. That means upward force is equal to downward force, and the upward force is the tension force of 0.53. And what is the downward force? Downward force is the weight that is acting vertically downward, and since it is an uniform cylinder, so the weight is acting from the center and is acting vertically downward. So resultant force is 0. That means upward force, that is 0.53 Newton, is equal to downward force, that is weight. So we get the value of weight as 0.53 Newton. Now we know the value of weight. Then the cylinder has a length given, so length and the cross-sectional area is given. The tension in the wire is 0.53 Newton. The cylinder is now lowered. So the cylinder is now lowered and then held stationary. So again it held stationary. So the resultant force, there is a sum of the force is 0, the resultant force is 0 by the wire, so that the top of the cylinder is level with the surface of the liquid. So the top of the cylinder, is level with the surface of the liquid. So the top of the cylinder is level with the surface of the liquid. So surface of the liquid, the top of the cylinder is level with the surface of the liquid. Calculate the new tension in the wire. So now we need to calculate the value of new tension. So first of all, erase this. So the tension force is acting upward. So tension is acting upward and the weight is acting from the center and is vertically downward. And now the cylinder is inside the liquid. So since it is inside the liquid, so the upthrust force is acting on the cylinder. So there is some upthrust because the cylinder is now inside the liquid. And what is the upthrust force? Upthrust force is equal to upthrust is equal to rho Vg, and what upthrust causes. So that means what is the direction of upthrust? So the direction of upthrust is upwards. So the direction of upthrust is upwards. So upthrust is acting upward, tension is acting upward, and the weight is acting downward. And the cylinder is stationary. That means the upward force is equal to downward force. So upward force, that is tension plus upthrust, is equal to weight. So we need to find the new tension. So tension is equal to weight minus upthrust. So what is the value of weight? So tension is equal to weight, that is 0.53 minus upthrust. And what is the value of upthrust? Upthrust is equal to rho, that is the density. So what is the density of the cylinder? So first of all, tension is equal to weight minus upthrust. So tension is equal to weight minus upthrust. So we know the value of weight, that is 0.53 minus upthrust. So now we need to calculate the value of upthrust. So upthrust is equal to rho Vg. So rho is the density. So density is equal to mass per unit volume. V is the volume and G is the gravitational field strength. So upthrust is equal to rho Vg, where rho is the density, that is mass per unit volume. V is the volume and G is the gravitational field strength. So volume and volume cancels. So upthrust is equal to mg. So upthrust is equal to mg. So what is the value of mg? Weight is equal to mg, that is 0.53. So the tension comes to be 0.53 minus 0.53. A solid cylinder is held stationary by a wire so that the base of the cylinder is level with the surface of the liquid. So the base of the cylinder is level with the surface of the liquid and the cylinder is held stationary. Since the cylinder is stationary, so by Newton's first law, we know that for an object at rest or moving at a constant velocity, the resultant force is zero. So the sum of the force or the resultant force is zero. So since the object is stationary, so the resultant force is zero. That means upward force is equal to downward force, and we get the upward force as 0.53 as the tension force. And what is the downward force? Downward force is the weight and no other force is acting. So resultant force is zero. That means upward force, that is 0.53, is equal to downward force, that is weight. So weight is equal to 0.53 Newton. Weight is equal to 0.53 Newton. The cylinder has a length given, so this is the length. So we know the value of length. And the cross-sectional area, so we know the value of area. Area, length, the tension in the wire is 0.53. The cylinder is now lowered and then held stationary. So the cylinder is now lowered and held stationary by the wire so that the top of the cylinder is level with the surface of the liquid. So that the top of the cylinder is level with the surface of the liquid. So this is the surface of the liquid, and so the top of the cylinder is level with the surface of the liquid as the cylinder is lowered. So and held stationary. So now the cylinder is also stationary. That means the resultant force is zero. So the upward force must equal to the downward force. Calculate the new tension in the wire. So we need to calculate the value of new tension. So first of all, for the cylinder, the tension is acting upward and the weight is acting from the center and is acting vertically downward. And since the wire is the cylinder is now inside the water, so the cylinder is now inside the water, so there is some upthrust acting on the cylinder due to water. So what is upthrust? Upthrust is acting upward. So what is upthrust? Upthrust is equal to rho Vg, where rho is the density of the liquid, V is the volume of the object, and G is the gravitational field strength. So rho is the density of the liquid and V is the volume of the object. So now for the new condition, we need to find the new tension. So tension plus, so the upward force is equal to downward force, and as resultant force is zero, since the object is stationary, so upward force is equal to downward force, and upward force is tension plus upthrust is equal to weight. So tension is equal to weight minus upthrust. So tension is equal to weight minus upthrust. And what is the value of weight? Weight is 0.53 minus upthrust. So 0.53 minus upthrust. And what is upthrust? Upthrust is equal to rho Vg, where rho is the density of the liquid, V is the volume of the object, and G is the gravitational field strength. So what is the density of the liquid? So initially we have calculated the density of the liquid, that is the density of the liquid as 765, or we can say that 764. So the density is 764, and the volume, so what is the volume of the object? So density of the liquid into volume of the object. So volume is equal to area into length. Volume is equal to area into length. So the length is 4 into 10 to the power negative 2, and the area is 3.7 into 10 to the power negative 4. So what is the volume? Volume is equal to area, that is 4 into 10 to the power minus 2. There is the length. Volume is equal to length into area. That is volume is equal to area into length. So we get the value of length and the area is 3.7 into 10 to the power minus 4. So what is the value? So the value of volume that we get is 1.48 into 10 to the power minus 5. So we get the volume that is 1.48 into 10 to the power minus 5. And you need to remember or look at the units that the units are correct. So it is meter square and meter, and the units are not in centimeters, so the unit is meter cube. And we know the value of density that we have substituted that the density of the liquid and the volume of the object into gravitational piston, that is 9.81. So what is the upthrust? So the value of upthrust that we get is 0.11 Newton. So we know the value of upthrust, that is upthrust. Well, now what is the value of tension? Tension is equal to weight, that is 0.53 minus upthrust, that is 0.11. So what is the value of tension? So the tension comes to be 0.42 Newton. So the value of tension is 0.42 Newton, that is 0.42 Newton as our final answer to two significant figures. Question number 5, part A. An electromagnetic wave in vacuum has the wavelength given. So we know the value of lambda. State the name of the principal region of the electromagnetic spectrum of the wave. So we know the value of wavelength. Now we can use the value, that is, so these values are the wavelength. So for radio waves, lambda, and these are the waves, that is electromagnetic wave. So for radio waves, it is 10 to the power 4 to 10 to the power negative 1. Then for microwaves, it is 10 to the power negative 1 to 10 to the power negative 3. Infrared radiation, 10 to the power negative 2 to 10 to the power negative 6. Visible light, 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7. Then UV light, 10 to the power minus 7 to 10 to the power minus 9. X-ray, 10 to the power minus 9 to 10 to the power minus 12. And gamma ray, 10 to the power minus 10 to 10 to the power minus 16. And you can memorize this easily by 4 negative 1, that is 4 negative 1, negative 1 negative 3, negative 2 negative 6, 4 into 10 to the power minus 7 to 7 into 10 to the power negative 7, then negative 7 to negative 9, negative 9 to negative 12, and negative 10 to negative 16. So you can memorize this by using these values, but this has no importance. And these are the wavelength, that is lambda, and you have to memorize these values. That is the lambda of the electromagnetic waves. Now, by comparing, we have given the wavelength as 8.4 into 10 to the power negative 6. That is 10 to the power negative 6. So 10 to the power negative 6. So 10 to the power negative 6 is in between 10 to the power negative 2 to 10 to the power negative 6. So negative 6 is negative 2 to negative 6. Therefore, the wave is infrared radiation. So the wave is infrared radiation, and it is not 10 to the power negative 7. It is 10 to the power negative 6. So it is only infrared radiation. And you have to remember these values. There is the value of wavelength and the electromagnetic waves that have these values. So calculate the frequency in terms of terahertz of the wave. So tera is 10 to the power 12 hertz. So tera is 10 to the power 12. So first of all, what is the value of frequency? So we know the equation V is equal to F lambda. So what is the value of F? F is equal to V by lambda. So we know the wave is electromagnetic wave. So for all electromagnetic waves, the speed is 3 into 10 to the power 8 meter per second. So 3 into 10 to the power 8 by lambda. Lambda is 8.4 into 10 to the power negative 6. So the frequency that we get is 3.6 into 10 to the power 13, or approximately 13 into 10 to the power 12. And 10 to the power 12 is tera. So 36 terahertz. So 36 terahertz. And tera is 10 to the power 12, giga is 10 to the power 9, mega is 10 to the power 6. Then arrangement that uses a double slit to demonstrate the interference of light from a laser is shown in figure 5.1. So light of wavelength given, double slit A, the distance D, and separation X. So separation X is not given right now. So the liquid from the laser has a wavelength lambda given and is incident normally on the slits. The separation of the two slits is A. So the distance between the two slits is A. The slit and the screen are parallel and are separated by a distance of 2.8 meter. So the distance is 2.8 meter. That is distance D. And the distance D is 2.8 meter. The interference pattern of the bright fringes and the dark fringes is formed on the screen. The distance on the screen across 8 fringes is 22 millimeter. So the bright fringes and the dark fringes are formed on the screen, and the distance on the screen across 8 bright fringes, so across 8 bright fringes is 22 millimeter. So the distance is 22 millimeter. Now, as illustrated in figure 5.2. So the distance is 8 millimeter. That is one distance, 2, 3, 4, 5, 6, 7, 8. So 1. So this is not 1, 2. Just we need to start from this value. So this value to this value is 1. then 2, 3, 4, 5, 6, 7, and 8. So 8 bright fringes are separated by 8 bright fringes are separated by a distance of 22 millimeter. So the distance between the two bright fringes or one bright fringe is 22 by 8. That is 22 by 8. We get a value that is 2.75 millimeter. 2.75 millimeter. So 75 millimeter. Now the light waves emerging from the two slits are coherent. So the light waves emerging from the two slits are coherent. That means they have a constant phase difference. Coherent means the waves have a constant phase difference. So what is meant by coherent? Coherent means constant phase difference between the waves. So coherent means constant phase difference between the waves. Coherent means constant phase difference between the waves. Calculate the separation A of the slit. So separation A of the slit. So this is a double slit experiment. So we can use the equation that is lambda is equal to AX by D, and we need to find the separation A. So A is lambda D by X. So what is the value of lambda? So the lambda is 6.2 into the power negative 7. So 6.2 into 10 to the power minus 7 lambda, and the distance D is 2.8 meter. So into 2.8 by what is X? So we get the value of X, or the distance between the two bright fringes. That is the distance between the two bright fringes. That is the distance between 8 bright fringes. So 8 bright fringes, 8x is equal to 22. So what is the value of X or one bright fringe? The distance between the two bright fringe or so the distance is 2.75. So 2.75 millimeter, or if we just convert this to meter, then 2.75 divided by 10 to convert this to centimeter, and divided by 100 to convert the centimeter to meter. That is 2.75 into 10 to the power minus 3 meter. So this is the value of X. So 2.75 into 10 to the power minus 3 meter. So what is the value of A? Now A is lambda, that is 6.2 into 10 to the power minus 7. So lambda into 2.8 divided by X. So we get the value of A as 6.3127 into 10 to the power minus 4. That is approximately 6.3 into 10 to the power negative 4. So this is the value of A. For part C, fringe P is the central bright fringe of the interference pattern. In B, fringe Q and R are the nearest dark fringe and the nearest bright fringe respectively to the right of P, as shown in figure 5.2. So fringe P is a central bright fringe, and Q and R are the nearest dark and the nearest bright fringe to the right of P. So P is the central bright fringe, Q and R are to the right of P, and Q is the nearest dark fringe and R is the nearest bright fringe. Now calculate the difference in distance, the path difference from each slit to the center of fringe Q. So what is the path difference? So what is the path difference to the center of fringe Q? So fringe P is a central bright fringe, and Q and R are to the right of P, and Q is the nearest dark and R is the nearest bright. Now from each slit, what is the path difference? What is the path difference from each slit to the center of fringe Q? So what is the value of path difference? So path difference between the adjacent bright fringe, that is bright and bright fringe. So the adjacent bright fringe, for the adjacent bright fringe, the path difference is lambda. But since Q is a dark fringe, so Q is dark and P is bright. So bright and dark fringe would be lambda by 2. Adjacent bright fringe, that is bright and bright is lambda, but bright and dark is lambda by 2. So P and Q are, P is bright and Q is dark. So bright to dark is lambda by 2. That is the path difference is lambda by 2. So lambda by 2. And what is the value of lambda? So lambda is 6.2 into the power negative 7 by 2. So 6.2 into the power negative 7 by 2, that is 3.1 into the power negative 7 as the path difference to the center of Q. State the phase difference between the light meeting at the center of fringe arm. So phase difference between the light waves meeting at the center of fringe arm. So what is the value of phase difference? So first of all, so we need to find the phase difference from each of the light to R, or the phase difference from the light meeting at the center of R. So phase difference meeting at R. So R is the bright and P is the bright. So between two bright fringes, the path difference is lambda and the phase difference is 360 degree. While from P to Q, since P is bright and Q is dark, so bright to dark is lambda by 2, that is the path difference, and the phase difference is 180 degree. So P to R, since bright and bright, so the phase difference is 360 degree. Similarly, if there is another bright point, that is the bright, then the phase difference would be 720 degree. So now the phase difference between P and R is 360 degree between the two bright fringes. Number 6. A metal wire in a circuit has a length of 1.8 meter. So the length is 1.8 meter. Cross-sectional area is 1.5 into 10 to the power negative 6 meters square. The total number of free electrons in the wire is given. So this is the total number of electrons, free electrons. There is a current in the wire, so that the charge of, we have given the value of charge that moves past a fixed point in the wire in a time of 2.5 minutes. So show that the number density of the free electrons is given. So what is number density? So you have to remember that number density is the number of free electrons per unit volume. Number density, that is N. So I is equal to NAVQ, where A is the cross-sectional area, V is the velocity, Q is the charge of an electron, and N is the number density. So number density is the number of free electrons per unit volume. So the total number of free electron is 2.3 into the power 23 by the volume. So what is the volume? So volume is equal to area into length. So area into length is a volume. So the number density comes to be 8.5 into 10 to the power 28 to two significant figure as shown. So SHOWN. That is 8.5 into 10 to the power 28. Then calculate the average drift speed of the free electrons. So we need to find the speed V. So V is equal to I by NAQ, where what is the value of current? So current is equal to charge per unit time. So the charge is 172 coulomb and the time is 2.5 minutes. So 172 by 2.5, and since the 2.5 is in a minute, so we need to convert this to second by multiplying with 60 divided by N. So this is the value of N. A is the cross-sectional area, that is 1.5 into 10 to the power negative 6, and Q is the elementary charge, that is 1.6 into 10 to the power minus 19 coulomb. So what is the velocity that we get? That is 5.6 into 10 to the power negative 5 meter per second to two significant figures. Number 7. A battery of EMF 9.6 volt and negligible internal resistance is connected in series with two fixed resistor and a thermistor as shown in figure 7.1. So two fixed resistor and a thermistor. So you have to remember that for thermistor, resistance is inversely proportional to temperature, and for light dependent resistor, resistance is inversely proportional to light intensity. So the fixed resistors have resistance 3400 ohm and 5800 ohm. The reading on the voltmeter in the circuit is 6 volt. So the voltmeter reading is 6 volt, and we have given the resistance. Calculate the current in the resistor of resistance 5800 ohm. So we need to find the value of current. So what is the value of current? Current is equal to, so we know that resistance is equal to voltage by current. So current is equal to voltage by resistance. So current is equal to voltage by resistance. And what is the voltage across this resistor? So we know the resistance, that is 5800 ohm. That is this resistor. And we need to find the value of voltage. So 9.6 volt. So 6 volt is dropped between this resistor and this resistor. So 6 volt is already dropped. Now what is the remaining voltage? That is 9.6 is the total voltage minus 6 volt is 3.6 volt. So 6 volt is already dropped between these two resistors, and the remaining 3.6 volt is dropped across the 5800 ohm resistor. So 5800 ohm resistor gets a voltage of 3.6 volt. So voltage by resistance, so we get the value of current as 6.2 into 10 to the power 84 ampere. So 6.2 into 10 to the power 84 ampere. Now calculate the resistance of the thermistor. So what is the resistance of this thermistor? And the resistance of thermistor. So resistance R thermistor. So resistance thermistor is equal to voltage by current. And in series circuit, since the resistors are arranged in series, that is, these resistors are arranged in series, so the current is same. And what is the value of current? So the current is 6.2 into 10 to the power 84. So resistance is equal to voltage by current, and the current is 6.2 into 10 to the power minus 4. But what is the voltage across the thermistor? What is the voltage across the thermistor? So we know the value of total voltage. And what is the voltage across 3400 ohm resistor? So voltage across 3400 ohm resistor, V across 3400 ohm resistor, voltage is equal to current into resistance. So we know the value of current, that is 6.2 into 10 to the power minus 4. And what is the resistance? So the resistance is 3400 ohm. 3400 ohm. So the voltage across 3400 ohm resistor is 3400 into 6.2 into 10 to the power minus 4. So the value of voltage that we get is 2.108 or approximately 2.1 volt. So the voltage across 3400 ohm resistor is 2.1 volt, and the total voltage between thermistor and 3400 ohm resistor is 6 volt. So voltage across 3400 ohm resistor is 2.1 ohm, so 2.1 volt. So 2.1 volt plus voltage across the thermistor is equal to 6 volt, because the 6 volt is drawed between this resistor and this resistor. So 6 volt is the total voltage. So what is the value of V? V comes to be 6 minus 2.1. So we get the value of V as 3.892. That is the voltage across the thermistor. So voltage across the thermistor, now 3.892 volt. So voltage by current, so 6.2 into 10 to the power negative 4. So the resistance that we get is 6.3 into 10 to the power 3 ohm. So 6.3 into 10 to the power 3 ohm as our final answer. So the resistance is 6.3 into 10 to the power 3 ohm. Now again, if we just discuss this, then we need to find the resistance of the thermistor. So we need to find the resistance of the thermistor. Now what is the resistance? Resistance is equal to voltage by current, and since the system is connected in series, so let me erase this. So the system is connected in series, or the resistors are connected in series. So in series circuit, we know that the current is same, and we have found the value of current, that is 6.2 into 10 to the power 84. So 6.2 into 10 to the power 84, we know the value of current. But what is the value of voltage? So voltage across 3400, voltage across the thermistor. So we need to find the voltage across the thermistor. So 6 ohm voltage, 6 volt is shared between 3400 ohm resistor and thermistor. So what is the voltage across the thermistor? Voltage across the thermistor, that is the total voltage 6 volt is equal to voltage across 3400 ohm resistor plus voltage across the thermistor. So what is the voltage across the thermistor? Voltage across the thermistor is equal to 6 minus 3400 ohm resistor. There is a voltage across the 3400 ohm resistor. So what is this voltage? So voltage is equal to IR, or V is equal to IR. So we know the value of current, and the resistance is 3400 ohm resistor. So the voltage that we get is 2.1 volt. So we know the value of voltage across this resistor, and we know the total voltage shared between this resistor and this resistor. So what is the voltage across the thermistor? So 6 is equal to 2.1 plus voltage across thermistor. So the voltage across the thermistor is 6 minus 2.1. That is 6 minus 2.11. So the resistance that we get is this value. That is approximately 6.3 into 10 to the power 3 ohm to two significant figures. The initial energy stored in the battery is 2.6 into 10 to the power 4 joules. Assume that the EMF of the battery is constant. Determine the final energy stored in the battery after a charge of 300 coulomb has moved through it. So we need to find the final energy that is stored in the battery. We have given the initial energy stored in the battery, and after a charge of 330 coulomb has moved through the circuit, we need to find the final energy. So we know that energy is equal to power into time, and power is equal to voltage into current into time, and current is equal to charge per unit time. So charge per unit time, so time and time cancels, and the energy comes to be VQ. So we have given the value of charge, and since the EMF of the battery is constant, so the EMF value is constant one. And what is the EMF of the battery? So the EMF of the battery is 9.6 volt. So since the EMF is constant, so constant value into charge, so the energy that is lost, or as the charge flows, this much energy is lost. Now what is the final energy? Final energy is equal to initial energy that is stored in the battery minus the energy lost due to movement of charge, minus the energy lost due to movement of this charge. So what is the final energy? The final energy that we get is 2.3 into the power 4 joules. The environmental conditions change, causing an increase in the resistance of the thermistor. So the resistance of the thermistor increases. Now for thermistor, we know that resistance is inversely proportional to temperature. So the resistance of thermistor increases. So as the resistance is inversely proportional to temperature, so if resistance increases, then what happens to the temperature? As the resistance increases, so the temperature must decrease. So the temperature decreases. Now for current in the thermistor, so what happens to the current in the thermistor? So resistance of thermistor increases. So as resistance of thermistor increases, so current is equal to voltage by resistance. So current is equal to, that is the total current is equal to voltage by resistance, and the total voltage is 9.6 volt, 9.6 volt. And what is the total resistance? So 3400 ohm plus R, that is the resistance across the thermistor, plus 5800 ohm, 5800 ohm. So what happens to the current? Since the system is in series, so in series circuit, as the resistance of R increases, while the EMF is same and the other resistance is same. So as resistance increases, current must decrease. Since here we can see that current is inversely proportional to resistance. So the value of current decreases. Now what happens to the potential difference across the thermistor? So the resistance of the thermistor has increases. Resistance increases. Now what happens to the potential difference across the thermistor? So the total EMF, that is 9.6 volt, is equal to voltage across 3400 ohm resistor plus voltage across the thermistor, that is R, plus the voltage across 5800 ohm resistor, 5800 ohm resistor. So what is the voltage R? So we need to find what is voltage R, that is VR. Is it increase or decrease? So VR is equal to 9.6 minus voltage across 3400 ohm resistor plus voltage across 5800 ohm resistor. Now, what happens to VR? So first of all, VR is equal to 9.6 minus, so resistance of, so voltage is equal to V is equal to IR. So the current, we consider this as I, and the resistance is 3400 ohm minus, since if we remove the bracket then we have to place a minus sign, I into 5800 ohm. Now this EMF of the battery is constant, and initially we have found that the current in the thermistor, or the total current, since the thermistor is arranged in series, so in series the current decreases. So since the thermistor is connected in series, so the current in the thermistor, or the total current in the series, is same. So in series circuit the current is same, and here we found that the current decreases. So current decreases and this current also decreases. So there is a minus sign. So here we can see that 9.6 minus these two values decreases. That is, current decreases. So the overall resistance decreases. That is, the overall voltage decreases. That is, this voltage decreases. And since current decreases, so this voltage also decreases. So 9.6 minus this value would give a greater value, because these two values decreases due to decrease in current. And as the voltage decreases, so 9.6 minus this decrease in voltage would give a value that is greater or a larger value. So the voltage across the resistor, or the voltage across the thermistor, must increase. Number 8. An isolated stationary nucleus X decays by emitting an alpha particle to form nucleus Y. So X decays by emitting an alpha particle, and alpha particle has 4 nucleon, and the nucleon number is the total number of protons plus neutron, and 2 protons. So alpha particles have 2 protons and 4 proton plus neutron plus Y. The nucleus Y and Z are isotopes of the same element. So Y, that is the emitted, and another nucleus Z are the isotopes of the same element. And for isotopes, we know that isotopes are the atoms of the same element with the same number of protons and electrons. So isotopes have same protons and electrons but different neutrons. So isotopes are the atoms of the same element that have the same number of protons and electrons but different neutrons. So Y and Z are isotopes. That means they have same protons and electrons but different neutrons. By comparing the number of protons in each nucleus, state and explain whether the charge of nucleus Y is less than, greater than, or same as the charge of Z. So Y and Z. So Y and Z are the isotopes. And isotopes are the atoms of the same element with the same number of protons and electrons but different number of neutrons. So since Y and Z are isotopes, so they have same protons and electrons. Same protons and electrons means they have the same number of protons and electrons. So Y and Z have the same protons and electrons since they are isotopes. So they have the same charge, because Y and Z have equal number of protons and also equal number of electrons since they are isotopes. So they have the same charge. Since proton number is equal to charge, or the proton number or electron number determines the charge. Suppose +2 or -2, this charge is determined by proton and electron. So Y and Z are isotopes. That means they have the same number of protons and electrons. Since they have same number of protons and electrons, so they have the same charge. Now, again, by comparing the number of protons, and here we don't need to mention about the electrons, since we need to state our answer by comparing the number of protons. So we need to only state the number of protons in our answer and not the electrons, because by comparing the number of protons, so we need to compare by the number of protons and not the electrons. So Y and Z have equal number of protons, so they have equal charge or same charge. Now by comparing the number of protons in each nucleus, state and explain whether the charge of nucleus Y is less than, greater than, or same as the charge of X. So Y and X. Now, as X decays, it emits 2 proton. That is, 2 proton is gained by alpha particle. So if let's suppose X has a proton number of P, then due to the emission of alpha particle, Y has a proton number of P minus 2. And these 2 proton are the proton of alpha particle. So as X decays, it emits an alpha particle that contains 2 proton plus Y. And what is the proton number of Y? Proton number of Y is equal to total proton minus 2. That is P minus 2. So Y has 2 fewer protons than X. Y has 2 fewer protons than X. So Y has less charge than X. Since Y has less number of protons, so it has less charge than X. So use the principle of conservation of momentum to explain why nucleus Y cannot be stationary immediately after the decay of nucleus X. So an isolated stationary nucleus X. So initially X is stationary and X decays to form alpha particle and Y. So an isolated stationary nucleus X. That means before the decay, this X decays to form alpha particle and Y. Initially X is stationary. And we know that momentum, by principle of conservation of momentum, momentum is always conserved. Since momentum is conserved, so total momentum before collision, that is momentum before collision, is equal to momentum after collision. Momentum before is equal to momentum after. So initially, we know that X is stationary. Since X is stationary, so momentum is equal to mass into velocity. So momentum is equal to mass into velocity. So as X is stationary, so its velocity is 0, so the momentum is 0. That means total momentum before the decay is 0. Since X is stationary before the decay, X is stationary before the decay, so the momentum is 0. That is total momentum before the decay is 0. Since total momentum before the decay is 0, so the total momentum after decay must be 0. That is the total momentum after the decay must be 0. That is total momentum before 0 is equal to total momentum after 0. And we need to state that Y nucleus Y cannot be stationary immediately after the decay, because as X decays to form Y and alpha particle, so X decays to form Y and alpha particle. Now as X decays, so Y and alpha particle both have momentum. Now since both have momentum, so to make the final momentum 0, Y and alpha particle must move in opposite direction with equal momentum. Since we know that before the decay, the total momentum is 0. So after the decay, the total momentum must be 0. After the decay, the total momentum must be 0 as momentum is conserved. Since after the decay, the total momentum is 0, so Y and alpha particle have equal and opposite momentum. So they have equal and opposite momentum. Since they have opposite momentum, so the momentum cancel and the resultant momentum becomes 0. That's why Y has equal and opposite momentum to alpha particle. Now again, if we just explain, then by principle of conservation of momentum, we know that total momentum before the decay is 0. Since X is stationary, so total momentum before the decay is 0. So total momentum before the decay is 0. So by principle of conservation of momentum, the total momentum after the decay must be 0. So before 0, after 0, since momentum is conserved, so the momentum after the decay must be 0. And for the momentum after the decay to be 0, as X emits alpha particle and Y, so alpha particle and Y must have equal and opposite momentum, because if alpha particle and Y has equal and opposite momentum, then two momentums can cancel and the resultant momentum becomes 0. So to make the resultant momentum 0, alpha and Y has equal and opposite momentum. So they both have equal and opposite momentum. Since they have opposite momentum, so left cancels with right, so the total momentum after the decay is 0. That's why Y cannot be immediately stationary after the decay, because Y has some momentum that is opposite momentum and equal momentum to alpha particle. So total momentum before the decay is 0. So total momentum after the decay must be 0. And since the total momentum after the decay must be 0, so alpha particle and Y must have equal and opposite momentum. So the momentums cancel and the final momentum becomes 0.